So, hi everybody. I'm Dan. My wife is Shannon. She's sitting right there in the middle. Those at home can see her, and everybody else can see her here. So we're going to talk about the night sky in August, and also we're going to follow it up with a little bit of space news because there's a lot going on, and I'm just going to pick the stuff that I think was interesting. Some of it is depressing, but some of it is fun. So let's see. Hold on. We're going to start close. We're going to start with the Earth and the Moon, and then we're going to work ourselves further away. So the first thing we're going to talk about is the Earth. Upper left-hand chart, that's the astronomical darkness hours. So we're going to August, and things are just going to get darker for longer. Right now, in the early part of the month, we're looking at about 6 hours or so of darkness. And then at the end of the month, it's going to be getting close to 8 hours at 7.7. So it's a pretty big transition. Some people are happy. Some people will be very upset about this. It's also going to start getting colder in the beginning of the month. Average temperature is about 70 degrees at night. And by the end of the month, it's going to be closer to 60. So winter is coming. And then we're going to move on to the moons. The interesting thing on the moon is that we have 5 interesting phases of this month. So it's a long month. August 1st is when the moon is at apogee, and also this is the first quarter moon. The interesting thing about August 1st is that this is when in 1609, Galileo first demonstrated his Rio telescope to a Venetian lawmaker. But people say that he's the one that invented the telescope. He really isn't. There was another person a Dutchman who attempted to patent a telescope. That's the exact same design with a convex lens and a concave lens to make a telescope in the tube in 1608. But he didn't get it. And the reason he didn't get it is that the patent office says there are other designs like it already that's out that you can get out in the marketplace. So even he wasn't the first one to invent it. So the ideal telescope has been around. But what Galileo did that's different is that his first telescope was grounded. The other ones are just glass that was kind of just made. I mean, it's kind of blown or whatever to be the convex and concave shape, but his is actually grounded out of solid piece, and also his tube is made of lead instead of wood. So it's a lot more stable, and he was able to get 8 times magnification on his very first one. And later on, he was able to get up to 30 times. So 30 times is about what modern binoculars can do. We move on to the next day, August 9th. That's going to be a first full moon of the month, and it's going to be the sturgeon moon. So I was looking at sturgeon moon, all these, strawberry moon, sturgeon moon. I didn't know what that was, and apparently this is one of those like farmer's almanac thing. And the sturgeon moon, they named it that because apparently August is the month where they are at their fattest and at the easiest to catch. So that's why they named it the sturgeon moon. The other interesting thing about August 9th is that was when Richard Nixon had resigned as the president of the United States in 1974. Yep. So the next interesting date is the last quarter moon, August 16th. That's going to be at when the moon is at closest orbit to Earth. And that day was interesting because in 1769, Queen Victoria of England sent a telegram to the then US President Buchanan. The interesting thing about that, though, is that that was the first overseas telegram. The letter was 99 words in total, and it was 509 letters. Each letter took 2 minutes to send. So it was Morse code, but it took 2 minutes because of the delay, because of the technology at the time. The transmission began at 10:50 and it ended at 4:30 a.m. The whole transmission took 1,018 minutes, and it was 17 hours in total to send 99 words. Instagram. Right. The wires didn't last very long. It lasted about a month before it broke down, and then they had to redo the whole thing. Next date is the new moon, August 23rd. Phobos was discovered on that day, and 5 days before that, its sister moon Deimos was discovered. They're the moons of Mars. They're two tiny little things, and they're both kind of potato shapes. The other interesting thing about this day is that this was when the first pedestrian was killed by a car in a collision in year 1896. So what makes this interesting, though, is that she was killed by a car that was being demoed at the Crystal Palace. Car was going at a blazing speed of 4 miles per hour. Right. She was hit, and then I guess she fell over, hit her head, and she passed away. But there was controversy. So the car was supposed to do 4 miles per hour. That was the top speed. But the salesman that was demoing the car had tuned the vehicle to go much faster. It was 4.5 miles per hour. And there was a major controversy. There was lawsuit, there was trial, but he was found not guilty. So she was the first one to get hit by a car and pass away. But she wasn't the first person to die in a car accident. That person is Mary Ward of in Ireland. So the way she died is that she kind of fell off the car while the car was being driven, and she died that way. But that name, Mary Ward, might be familiar to a lot of people, especially people that's into astronomy, because she was involved with astronomy. Her cousin, one second, her cousin is William Parson. Oh, yeah, it's still on the screen because I didn't do it next slide. So the William Parson, he built and operated the Leviathan of Parsonstown. It was at the time the biggest telescope in the world. It was 6-foot refractor. Reflector. It held that record for quite a number of years. And what she did is she made all of the drawings while it was being built. She also made a bunch of drawings while it was in operation. So when this telescope was burned down, they used her drawings to rebuild it. One second. This is her drawing of the telescope. It's a gigantic reflector that's in the ground. There's 2 ladders on the side. You can go up it, and there's a gantry that comes out to the eye port. So it just goes up and down. It doesn't really move in any other directions. Right? Big. And this is the real thing after it's been reconstructed. So, yeah. I'm not sure if it was operational, but that's the telescope that she made. And she was the first person to die from a car accident. The next day is going to have the first quarter again on August 31st. And that was when the first chemotherapy happened. So that was, the first chemotherapy wasn't to treat cancer, it was to treat syphilis on a bunny. Kind of sad. It was actually at a time called preparation 606. It was made of 2 arsenic compound, and the bunny was given syphilis before, and then they used it to treat it on the bunny, and apparently it was successful. And the man who invented it ends up coining the term chemotherapy. Okay, so that's Earth and the Moon, and those are the interesting dates. So next, we're going to talk about planets. The interesting things is obviously the shadow transit of Saturn by Titan, and there's one on August 3rd, which just passed. There's another one on August 19th. There's going to be another one on September 4th, September 20th, and October 6th. And it's going to be a while before that happens again. So those are the dates to keep in mind to see the Titan shadow. On August 6th, which is today, Saturn and Neptune will be kind of close to each other at about 1.1 degrees apart. We kind of missed it already, but it's still pretty close tonight if you look at it, or in the morning. The next is going to be the conjunction of Venus and Jupiter, the two really, really bright planets. Just before sunrise, Jupiter will catch them. They are even closer than Saturn and Neptune at 0.9 degrees apart. They're going to be located right in the middle of Gemini. And at the closer to the end of the month, August 20th, we are going to have 6 planets alignment, kind of, because Mars is actually going to be below the horizon, but all of the other planets will be up there. And also, you're going to have a very nice crescent moon joining Venus and Jupiter. So the moon is actually not going to drown them out. You're going to be able to see them. There's also going to be Uranus up there as well. You're not going to be able to see that without telescope. There's going to be Neptune and Saturn that's going to be kind of close up there as well. And if you wait a little bit, Mars should come up, but you're going to be fighting the sun then. The big news, though, for the month of August is the Perseid meteor shower. It's going to peak on August 12th and 13th. But you're going to have a almost full moon up there kind of fighting you. You're not going to see much, and they predict that it's going to be 10 to 20 meteors per hour instead of the typical 50 to 100. Not sure how much we are going to see here on the island. We have enough light pollution without the moon, so good luck.
We were at Moses, 6 of them in a minute.
Okay.
First one, I was like, wait, what did I see? And then
Neat.
yeah,
Neat. Yeah. The source of the Perseid meteor shower is the comet Swift-Tuttle. Swift-Tuttle is interesting because it's actually one of the most well-documented ancient comets. It's been around for a long time, and we've been documenting it. So there are comets, cave drawings, and so on, but this one was actually written down. Since 322 BC, it was the first recorded incident by a Chinese astronomer that was written down, say there's a thing in the sky and it's lighting up the whole thing, and there's hails and so on. And then again at year 69 BC, and then again at 188, and so on, so on, so on. It was recorded multiple times. When it was recognized as a comet was in year 1862. There was a German Jesuit missionary in China at the time, during the Qing dynasty, and he went there and he looked at the books and he saw that there's an event that happens every couple of 100 years, and in that year, he should be able to see something in the sky if it's true. And sure enough, he did, and he recognized it, and and people said, "Hey, that's comet." Last time it passed through here is in 1992, but it was remained visible till 1995. There was a last picture of the comet, and the next time it's going to be here is going to be in year 2126. So whoever's going to be around by then, make sure you take a good picture. All right, deep sky. August have a decent amount of objects up there, and all these objects that you see on the screen will be around for almost the entire night. So obviously there's Albireo. It's a double star that's going to stay up there. It's going to be in the middle of the summer triangle, Vega, Deneb, and Altair. If you look at it, it's pretty cool. It's gold and blue in color. Obviously, don't do what Shannon and I did, which is try to look through it through an image intensifier, and everything just looks green. And we just see 2 green dots. Yeah. So close to that, just south of it, it's in the same constellation of Cygnus. You're going to see the Dumbbell Nebula, very popular. It's a planetary nebula. It's just going to be south of Albireo. And then another double star, Epsilon Lyra. It's known as double because when you look at it, it's a double star, but then once you zoom in, it's going to split again. Each of the double star is its own double star. So you're going to see 4 stars up there floating really close to each other. And close to that is in the constellation Lyra is the Ring Nebula, is another planetary nebula. Planetary nebula is interesting because that's the eventual fate of our sun. Our sun is going to go this route. We're not going to have a supernova. It's not massive enough. It's just going to balloon up into a red giant, and then the outer layer is just going to go poof, go outward. Oh, thank you. The and of course, you're going to have the giant Andromeda galaxy floating up as well, and that's going to start rising at around 9 to 10 o'clock, and it's going to be up in the sky all night for anybody that wants to see it. And so is the Triangulum galaxy. Those are two closest giant galaxy, and they should be visible by naked eye, but not on the island. And of course, we're going to talk about a double cluster that's kind of just west of Andromeda galaxy. And that region is actually interesting because not just you could have the double cluster, you also have the Perseid there. And that's going to be the origin point of the Perseid meteor shower. There's also the Hart Nebula that's kind of popular as well. And that's pretty much it for the night sky. So we're going to talk about news next. Next, space news. We're going to talk about space flights. We have been very busy. We've been trying to go to the moons. Us, mostly this year, we have launched a bunch of missions. However, only one truly has been a success. That would be the mission called Blue Ghost by Firefly Aerospace out of Texas. They landed, they were successful and operated for 14 days. An interesting thing about that Firefly Aerospace is that's where an intern that worked for me actually ends up going. He was an intern there for the next summer, and his name is actually on the plaque next to Blue Ghost on the moon. And his mom is obviously extremely proud, and she sent me a picture of it, but she said he would not have it on the fridge. Next mission is a Japanese mission. It crash landed. This is the second attempt by them, and I saw it live, and it was kind of shocking to see their reaction of just sadness. The feed kind of just cut away, and it was sad. And there's also the Intuitive Machine, very popular, has a lot of hopes on it because it's actually a really big lander. It carries a couple of rovers and a couple of science equipment. Unfortunately, this is also their second attempt, and it wasn't a success. It landed, but it landed relatively hard and broke one of its leg, and it tipped over. So it couldn't get enough power. It only operated for a few hours, just sitting there. It couldn't launch any of its test vehicle. So the Intuitive Machine was launched on a satellite bus with two more satellites that was destined for the moon. There was the Lunar Trailblazer by NASA, and then there's the Odin by Astroforge. Unfortunately, those two were also lost in space. NASA lost contact with Lunar Trailblazer on its way to the moon. It just wasn't communicating. And initially, they were still looking, even as of this morning, I thought. But then I saw news today before I came here that NASA had given up on it. They believe that the satellite wasn't pointed at the moon, the solar panel, and they couldn't get enough power. So there's no communication at all. Astroforge Odin wanted to fly by an asteroid before going to the moon, but it was the communication was lost then too, and they declared themselves a failure and didn't go. There are a few more missions coming up. The Griffin 2 by Astrobotics, that's out of Pennsylvania. Intuitive Machines wants to launch again, and then there's the Blue Origin, Blue Moon. Blue Origin, Blue Moon is supposed to be a big deal. It's one of the programs that's tied to the Artemis program, which we'll talk about in 1 second. All of these are destined to launch at the end of this year, but I think Intuitive Machine is pushing it back till next year at this point. Every single one of them is private, including the NASA ones operated by NASA, but the launch vehicle wasn't. Majority of them is funded by NASA, though. I mean, they're private, but they also have a lot of government funding, except for iSpace. iSpace is a Japanese endeavor. So the reason we're going to the moon, and there's a bit of a space race between us and the Chinese, and it is a big deal. So we are trying to land on the south pole of the moon. The reason we're going there is that we found water on the moon. There is water on the moon. They're frozen, but they are at the bottom of craters on the south pole. So the south pole of the moon is quite pockmarked with a bunch of impacts. And on the rims of them are really, really tall, so you get effectively 24-hour sunlight. So you get power, and you have water and other resources that are frozen. So now you can effectively have a colony there. You can have water, you can have fuel by breaking down water, and you have 24/7 power. So both and the Chinese are trying very hard to get there. The reason that we want to go there first is that both nations says we're not going to claim any property on the moon. However, once you start a colony there, it will be difficult to land around a colony simply because of safety risk. If we were to launch another spacecraft, it's going to be very difficult to land where we know there's stuff. So we're still trying to be the first. So the Chinese mission is called the International Lunar Research Station. They're working mostly by themselves, but there's the BRICS nation that's kind of working with them as well, and a couple of other partners nation. We have the Artemis program, and that have 56 countries that have signed up with us. At this point, the way the space station that we want to build is quite different between the two countries. The Chinese space station is mostly going to be a robotic mission. It's going to be pretty empty and not going to be fully staffed until 2035. They're going to attempt to land in 2030 with people, but then they're going to leave, and they're going to leave it empty for about 5 years. During that time, they want to build with robots. They have already launched quite a lot of missions to the moon, mostly to the far side of the moon and also on the South Pole. So they did do a couple of things, and right now their success rate to go to the moon is very high. It's very close to 100%. They landed on the far side of the moon and returned sample to us, and this was the first time we had samples. The humanity had brought back samples from the moon in about 50 years since the Apollo days. They're launching next year, this time directly to the South Pole with one of their biggest rover. It's going to have an orbiter, it's going to have a rover, and there's going to be a new robot that they want to bring there called Hopper. I don't have a picture of it, but it's a 6-legged robot that walks and hops. It's a miniature version of the ones that they eventually want to build. And what they want to do with that robot is that in its belly is going to be effectively a 3D printer where it's going to take the moon rocks or moon dust and use that as a building material to build their base out of. So like I said, 2030 is their planned target date to launch astronauts to land on the moon, but then it's going to leave it empty until 2035 where they staff it again. Between them, it's going to be just a fully robotic operation where they're building a base. They have a backup plan if they don't get to the moon in time, which is to bring nuclear power there. They are exploring both fission nuclear reactors, so that's a proper nuclear reactor. They're also looking at nuclear thermal battery as well. So our program right now, we are launching Artemis 2 next year, and there's a lot that's riding on it. Artemis 2 will be the last mission to fly on the NASA SLS rocket. SLS rocket is going to be retired because it was deemed too expensive. It's going to be replaced by SpaceX Starship. But we have one more to launch, and that's going to be at the end. It's going to be at the beginning of next year. And they have the crew already. It's just going to be a lunar orbit and come right back. They're not going to attempt to land there. It is very risky because during Artemis 1 launch, they didn't test the life support system of this module that they're sending. So typically you want to send one over there, fly around with the life support system running and tested. But this time they don't have enough rockets to go. So they're going to test the whole thing at once. The next stage is the Artemis 3, and that's the crew landing. Initially, it was supposed to be mid-2027. However, Starship has been having problems. The last 4 launches, I believe, had failures. They exploded, and one actually exploded recently on the launch pad that damaged the launch pad. This is all on what they call the Block 2 Starship, which is the second generation of Starship. The first Starship was very successful, but it wasn't full power. Starship 2 is full power with, I think, 37 booster inside of it. They're also having a problem with the Artemis 2 spacesuit as well, but they are working on its kink. The mid 2027 launch date is very ambitious. I believe they have another Starship launch this year, and that needs to be successful. Otherwise, we'd risk pushing it back further. The other thing that we have that's going to be interesting is called Lunar Gateway. It's effectively a space station that's going to be floating around the moon in a lunar orbit. That's going to be where we send people to, and then they land from there to the moon. It's cool, and I think that's going to go ahead because that's relatively low risk. They are launching two of the first module late next year, and they're using the Falcon Heavy, so it's relatively low risk. Falcon Heavy is very reliable at this point. They also have a bunch of commercial partners. A bunch of the mission that you saw earlier, they're all part of that program. They want to start building up a bunch of people that can go, drive effectively delivery vehicles, test vehicles, and so on to the moon. And they want to have it be fully operational by 2030. But again, it's running into a little bit of problems. And also today, I saw a headline that we are also now exploring bringing a nuclear reactor to the moon as well, just in case we don't get South Pole. But there are other craters where we believe there's water or deposit at the bottom of the crater where it's effectively shaded by the high wall from the sun. So it's always cold and there's a lot of liquid, ice water, solid water down there. So that's the mission to the moon. But we're now going to talk about something that's even more depressing: low Earth orbit. There's a journal that came out, a journal paper that came out that says that the Starlink satellite is not just obscuring our views, but also affecting radio astronomy as well. So Starlink satellite is supposed to only broadcast in certain frequency, but there's leakage whenever you do electronics, and the tiny amount of leakage that they have is now starting to affect radio astronomy. So they are calling for a stricter industry guidelines to prevent that. But that's quite difficult and expensive to do, especially when you're trying to limit weights. The other thing is that the low Earth orbit is getting very, very crowded. I'm not sure if you can see the numbers here, but right now this is 2024 data, we have 8,400 low Earth orbit satellites. These are functional satellites, not including discarded parts and discarded satellite. These are just functional ones. And most of those, 75% of those, is the Starlink satellite by SpaceX. The second biggest group is called OneWeb, doing pretty much the same thing. And I think they're out of Pennsylvania, but I'm not 100% sure. And then the rest of them, you can see down here as to who operates them. So this is 2024. By 2030, they're estimating we're going to have 35,000 satellites in low Earth orbit. Right. It's a lot more satellites than anything that we've ever seen before. It's going to be very crowded. There's a bunch of proposal as to leaving holes in low Earth orbit that nobody operates in so that we can have clear line of sight and clear out for some of our other science mission that goes further out, and geosynchronous orbit and all that. But 35,000 is quite a lot. And to make things worse, there isn't a really good single bodies that's monitoring it. Let me show you how many satellites up there right now. Oops. Actually, I have this open already. Yeah. So there you go. This is all low Earth orbit satellite. Every single green thing. And everything that you see that's yellow are rocket bodies and debris are just floating up there. Those little red cone that you see are the people or government that's actually monitoring the space. So this is everything they can see. So everything that they can see is here, and what you don't see, whether you don't see a red cone, is kind of just a mathematically calculated orbit. So they think that's where the stuff is, but there are certainly moving satellite around as there's a collision risk and so on. They're trying to avoid it, but right now there's only 8,000. In a few years, it's going to be 35,000. So that's a little scary, but we're going to talk about something more fun right now. Um, Telescopes. Vera Rubin. Um, Vera Rubin is amazing, and it is awesome. And there's a web page called Sky Viewer app that lets you kind of interactively see some of the first photos out of Vera Rubin. And also, there's an upcoming talk on October 8th by our own Steve Bellavia. He's going to be talking about the Vera Rubin camera that he worked on. So definitely go see that. So let me just show you the app of what that thing looks like. So this is the Sky Viewer app. If you go to that app, there's a web page. You could go see, I want to explore. You will see pictures from Vera Rubin, and you can zoom in and out and see some incredible things. And one of the coolest things I saw, just zooming in, is that there are, oops, there are 3 galaxies next to each other. And yeah, and actually every single dot that you see is effectively a galaxy. So every single thing. If you zoom out, you will see some stars. I think, unless they got rid of them. The way you used to be able to tell stars is that you can see the spikes on it. Yeah, there you go. Oops. There's a star. But the rest of it is galaxy. So I thought it was pretty cool. But I'm looking forward to the talk by Steve Bellavia on October 8th. So mark your calendars. On the right-hand side, you have a bunch of telescope and their diameters, their primary mirror diameter. Vera Rubin is right here. Bottom left, James Webb. Here's Hubble Space Telescope. And if anybody's been there, there's the Yerkes Observatory, and that's the biggest refractor telescope at the time. It's 40 inches. All right, so Shannon said these two are for scale tennis court and basketball court. So the size of these mirror. So something interesting one that's on here is, oops, well, you can't click on it. There you go. So interesting one is the Keck Observatory in Hawaii. It's up here. So Vera Rubin, we talked about, and there's Gemini North in Hawaii and Gemini South in Chile. Gemini North just did something incredible recently, and we'll talk about that soon. There's also the Very Large Telescope operated by the Europeans in Chile. And what's interesting about those is that there are 4 really big optical telescopes that's down there that are very close together. And they're doing something that other telescopes haven't really done, which is to do interferometry with optical telescope. And the close distance for them is necessary for them to do that. Usually you do that with a radio telescope. That's how you can have so many working at once. With optical, it's a little bit different. But they found a way to do it. And this is the Very Large Telescope. And this is the way Europeans like to name their telescope a lot of time, I find, because the next one that they're building is called Extremely Large Telescope. They're very creative with their names, but it's certainly true. I mean, look at the size of this compared to everything else out here. And we, taking a cue from them, have a telescope that was planned called 30-meter telescope, but at least it's not just extremely large. But the 30-meter telescope right now is questionable whether that's going to happen or not. I think the plan is at this point frozen. There is some talks that we are planning to sell the plans to the Europeans, and I'm not sure what they're going to call it, probably a mediumly large telescope. We do have the Magellan telescope that should be that's operating, and I think we have the Giant Magellan that's going to be coming up online soon, and it looks interesting. And if you look in the background, there's this big gray circle. Again, it's European. Initially, they called it overwhelmingly large telescope. Right. Unfortunately, right now, the overwhelmingly large telescope is canceled, mostly because of funding issue. And I'm willing to bet that Chile is getting quite crowded for a telescope at this point. There's a lot that's operating there. And the 2 big radius that you see on the bottom is radio telescope. That's the Arecibo, which unfortunately had collapsed. And there's the 500-meter telescope. Again, these are radio telescopes, so they can be very, very big. But everything else you see that's in color right here is optical. So they use mirrors and so on. So this is a ground-based telescope. And for the next few years, it's going to be very interesting because especially with the extremely large telescope. I think they will make extremely nice pictures. Yes.
By the way, the largest
Mhm. This one right here. Oh, wow. So those at home that haven't heard it, that was Dave that's saying that the Hobby Elderly Telescope is the only telescope that's open publicly where we can actually go see through it. That's going to be very cool. So if you ever go down to Texas, you knock on their doors. Next, space telescope. There isn't too many big diameter space telescope. And big diameter, I mean anything kind of like over 1 meters. We have the Hubble's up there at 2.4. That's the original. It was launched in 1990. It's been upgraded a few times with new electronics and so on. I think 4 or 5 times last time I looked. There's a James Webb that was recently launched at 6.5 meters. And that's all the way out there, Lagrange point 2. And of course, you saw some of the images that came out there. That looks incredible. There's a Nancy Grace Roman, which we had a talk about recently. That's going to be launching in 2027 if everything goes well. And then the first larger diameter telescope from the European, the Plato at 1.2, is going to be launching as well in 2026. Not too far from that is the Chinese with their first large diameter telescope. The I think it's pronounced Shuntian. It just means sky surveyor. This is their sky surveyor telescope, and it's 2 meters large, and it's going to be launching next year as well. But what's interesting about that telescope is that it's actually going to be sitting right next to their space station. And the reason they're doing that is so that they can do spacewalk to it and do upgrades as much as they want. Everything that we launched to L2 is kind of out of reach for us. We can never touch it. We can't do anything. I think we might be able to refuel it, but even that is kind of tricky. So this is, on the left here, is the wavelength coverage for each of the telescope. Hubble, at this point, has been the only one that's been able to see in ultraviolet. And ultraviolet for space telescope is actually quite interesting and important because we can't see that on the ground. The ultraviolet light that comes in gets immediately scattered by the sky, and you can't use it as an imaging device. Hubble can, and the new Shuntian can as well, but it doesn't go as deep. And James Webb is over here, where it goes all the way to what they call mid-infrared. That's why you see some of these amazing images, and that's why they can look back that far back in time and that far away and distant. On the right-hand side is the mirror size to scale in comparison of how big some of these telescopes are. The interesting thing, obviously, is Nancy Grace and Hubble's have the same exact diameter telescope mirror. There was some rumor that says Nancy Grace is built out of spare parts from Hubble, but that is not true. I think NASA has more money than that. This is, yes.
That comment, I think Nancy Grace Roman is using some part from planned spy satellite.
Okay. That never happened. Okay. This is supposed to be our next generation telescope. This is humongous. It's called I don't know how to pronounce it, LUVOIR. It stands for Large Ultraviolet Optical Infrared Surveyor. This is Hubble on the left. This is James Webb. These are the two proposed plans for their primary mirror. And unlike James Webb, this is supposed to see into ultraviolet as well. And they also want to park it in at L2. This is supposed to see everything. But there's a big question mark as to whether this can actually happen right now. Right now, they're not even proposing it. They wrote up a plan, but that's about it. So James Webb, when launched, and the maintenance and so on, it's estimated to cost about $10 billion. And the whole thing, I think, took something like 20 years to build. This, they are proposing the budget to be about $19 billion. So it's quite a bit more expensive. And if everything goes well, if it gets funded today, they think they can launch by 2039. But don't know if this is actually going to happen. Next, this is the last thing, Betelgeuse. We have found its companion star. So there's been a long rumor that Betelgeuse has a companion star because Betelgeuse behaves kind of funny. It has a weird wobble and it kind of dims and then brightens up again. They have been predicting a companion star for a long time, and they actually had the Hubble's and the Chandra Space Telescope looking, and they couldn't find anything. So it didn't happen for a long time, but the telescope that we talked about, the Gemini North in Hawaii, was able to find it. They use a newish camera called the Alopaki, I think, and they were able to find this companion star. So this companion star is tiny in comparison to Betelgeuse. This is only about 1.5 solar masses, so just about the size of our sun. A little bit bigger, but it's there, and it's orbiting very close to Betelgeuse. So Betelgeuse is a red giant. Betelgeuse is about 3 or 3.5 AU in diameter. So that's about from if it's sitting where the sun is, the orbit will the outer shell is kind of close to where Jupiter is. So it's very, very big. It's a little bit closer, maybe like to like the asteroid belt, but it's there. But this little guy is orbiting very close to it. And the interesting thing about it is, well, one, the name. I can't pronounce this name, but it's in Arabic, and the name translates to her bracelet. The reason it's called that is that the Betelgeuse original name is also in Arabic, and it translates to hands of Gemini, because apparently the Gemini constellation in the Arabic world at the time was it looks very different, and Betelgeuse was part of that constellation, not part of Orion like we have now. So in honor of that, this is the name for the new companion star. It's called her bracelet. The tight separation between them is they compare it to trying to separate the car headlights that's in the front of your car from 50,000 miles away. That's the kind of resolution they're looking at. The camera that they came up with to do this on the ground space telescope is interesting. It's very low resolution at 1024 by 1024, but it has a field of view of only about 6.7 arc second. Its resolution per pixel is 0.0096. So very, very fine pitch camera. And the way they take pictures is not with long exposure. In fact, it's the opposite. They did very, very short exposure. And the reason they did it is to get away from atmospheric disturbances. So they just take a bunch of really, really fast picture. The exposure can be as short as 14 milliseconds. So they just have this thing firing away, and then they stack the picture. Also, this companion star is not technically a star yet. It hasn't started burning fusion, so it hasn't even kick-started its life cycle yet. It's only about 10 million years old, but so is Betelgeuse. But Betelgeuse, because it's so massive, is actually at the end of its life. Within the next 10,000 years, either Betelgeuse is going to blow up into a supernova and burn up this star, or the star is going to spiral into Betelgeuse. Either way, this star is not going to be around for too long. And that's pretty much it for the space news that I found interesting. Going back to the moon for a second, I was trying to, I guess, visualize the distance between Earth and the moon and the scale. And one of the more interesting things that I found, and I looked it up, and apparently it's correct, is that if the Earth is, you imagine Earth to be the palm of your hand. So, that's about 3 inches or so. And you hold up a quarter in the other hand, and you have your arm outstretched. That would be the size and the distance between Earth and the moon. And that's what we're trying to land on. So if anybody try to tell you, try to ask you how far away moon is, that's your visualization. Hold a quarter in your hand and open your palm on the other. And the other interesting interesting fact is that you can fit every single planet in our solar system between Earth and the Moon, and with a little bit of space to spare. We don't count the rings of Saturn though. And in that scale, outstretched arm, if you put Jupiter right next to Earth, it will go from the wrist to about the middle of your body. That's the diameter, and it's a big circle. And Saturn will go from the middle of the body to about your elbow. And then the rest is fill-in planets. You got the two bigger planets, and then the rest is effectively dots. So that's it. This is everything.